So our new way of looking at trigonometric functions gives us a much increased ability to infer what values are based on just knowing, for example, one value. Okay, so take a look at this situation, right? I want to find all 6 trigonometric functions, sine, cosine, the whole lot of them, for an angle that passes through that point. -5, -12. Okay, obviously that point is more than 1 unit away from the center, from the origin, so it's not going to be on the edge of our unit circle, right? But that's okay. It's over here in the 3rd quadrant, so I'm going to kind of just approximate it here. It's down here somewhere, right? And the coordinates of this point are -5, -12. Right, so the angle that this represents, right, it's here. This is my terminal side, and the initial side is where it always is. So this is the angle that we're talking about. I don't know how many degrees it is, how many radians or whatever its measure is, but that's okay. I can still answer these questions because I know if I draw my right triangle, right, I have this reference angle here, and I know that the sine, cosine, and so forth of the angle that I'm looking for are going to match the sine, cosine, and so forth of this reference angle, give or take a negative sign. All right, so let's see. Let's see if we can work this out. This distance is -5. We're going to go ahead and make it negative. I know we don't usually do that with distances, but we'll go ahead and do that here. This distance is -12. Doing that is going to make the signs just kind of naturally come out right? But you'll see that as we go along. So let's call this angle here theta. Right? So then I know that the sine of theta is the opposite over the hypotenuse. So that's going to be -12 divided by, okay, the hypotenuse. What's the hypotenuse of this thing? Well, look, this is a right triangle, and its sides are 5 and 12. So let's just use the Pythagorean Theorem. Right? Call the hypotenuse h. Then h squared equals 5 squared plus 12 squared. That's 169. And then we'll take the square root of both sides. H is 13. Good. So there's my sine. Sine of theta is -12 over 13. And that means the cosecant of theta is -13 over 12, right? Because it's 1 over the sine. All right, so then let's see. The cosine of theta, that's the adjacent side divided by the hypotenuse. So this is going to be -5 divided by 12, which makes the secant 1 over that, right? Just flip it over. It's -12 fifths. Then the tangent is, let's see, sine over cosine. So that's -12 thirteenths over the cosine. Well, that should have been 13 there, not 12. Over -5 thirteenths, which is 12 fifths. And then finally the cotangent, flip the tangent over. It's going to be 5 twelfths. And there's my 6 values. Okay, so how about this situation? So in this situation, I don't know where the terminal side is like I did with the last one. All I know is the sine of this angle, right? So, where is it? I'm trying to find the other 5 values. All right, well, look, first, if the sine of theta is 0.23, then I get the cosecant almost for free. The cosecant is 1 over the sine, so it's 1 over 0.23, which is 4.348. Okay, that's the easy one, right? Now, let's see. What I know? Well, let's assume this is a unit circle, right? It's got a radius of 1, and I know that the sine is 0.23. Remember, that's the y-coordinate. So that's the height of the point, if you will. So 0.23, I don't know, it's a quarter, a half is here, a quarter is around here, which means my angle either goes through this point, in which case it looks like this, or the other point that has that y-coordinate is this one, and it looks like this. All right, well, which one is it? Okay, here's where I'm going to use the other piece of information we were given. The cosine is negative. All right, well, the cosine is not negative in the first quadrant, so this one can't be our angle. It has to be this one that's over in the second quadrant, right? Because in the second quadrant, the x-coordinates are negative, which means the cosine is negative. All right, great. Now I can keep going. Let's see. I know that if you can draw a right triangle, I'm going to get my reference angle in here just like we've been doing. I'm going to draw this. This distance is 0.23. This distance is 1, right, because it's a unit circle. Now, to get the x-coordinate of that point, I need this distance, right? But I can get that, right? This is a right triangle that I'm sporting here. So I can apply the Pythagorean Theorem. 0.23 squared plus x squared equals 1 squared. So let's move the 0.23 squared over. X squared equals 1 squared minus 0.23 squared. And then take the square root of both sides. X is the square root of 1 squared minus 0.23 squared. And my calculator tells me this is 0.973. All right, well, that means this distance is 0.973. Only we're going to the left, which means the coordinates of this point are negative 0.973, comma 0.23. And that's what I needed to know. Right, now I know the cosine of theta is negative 0.973, which means the secant of theta is 1 over that, which is negative 1.028. The tangent, see, it's kind of all downhill from here. The tangent is the sine over the cosine. So that's 0.23 divided by negative 0.973, which is negative 0.236. And the cotangent is 1 over the tangent. 1 over negative 0.236 is 4.237. And there you go. There are my 6 trigonometric values. And I don't even know what the angle is. Right? I don't even know. There's a way you can find out the angle, and we're going to get to that at a few lectures later on. But for now, I didn't need it. Right? I was able to fill in all of these values without having that piece of information. Okay, so let me give you one. Take a look at this. Right? See if you can pause the presentation, work through this on your own, and see what you come up with. All right, so I'm starting off with secant theta is negative 1.4. We'll do the easy one first. Secant is 1 over the cosine, which means the cosine of theta is 1 over negative 1.4, which is negative 0.714. All right. So now that's the one that I'm going to play off of to find my other values. If the cosine is negative 0.714, that's again where we've got to think of this unit circle, right? Radius is 1. That's somewhere over here. So I'm looking for an angle that goes through this point or an angle that goes through this point. All right, well, if you look up here, we know that the sine of theta is positive. Remember the sine, that's the y-coordinate. And of these 2 points, it's this one here, the upper one, the one that's in the second quadrant, that has a positive y value. So I don't want that angle down there. This angle here is the one that I'm looking for. Right, and what do I know about it? I know that this distance here is 0.714. The hypotenuse is 1, right, because unit circle. So I want to find that y-coordinate. I want to find this distance. And again, right, we've got a right triangle here, so I'm going to use the Pythagorean theorem. Y squared plus 0.714 squared equals 1 squared. So move the 0.714 over. Y squared equals 1 squared minus 0.714 squared. And then I'll take the square root of both sides. And my calculator tells me that this is 0.700. And I do want it to be positive, right? Because we're in the second quadrant. The y-coordinates are positive. So the coordinates of this point are negative 0.714, comma 0.700. And that's all I need. Right now I can get all my other values. The sine of theta is 0.700. The cosecant of theta is 1 over that, which is 1.429. The tangent is the sine over the cosine, so that's 0.700 divided by negative 0.714, which is negative 0.980. And finally, the cotangent is 1 over the tangent, 1 over negative 0.980 is negative 1.020. And that's it, right? That's all there is to it. There's my 6 values for this function. What kind of angle is this? About how big do you think this is, right? If you look at the tangent and cotangent. The tangent is really close to -1, and I know that the angle with a tangent of -1 in the second quadrant is going to be 135. It's got to have a reference angle of 45 degrees, right, to give it a tangent that's whose absolute value is in the neighborhood of 1. So this is going to be somewhere fairly close to 135 degrees. Okay. Now what? Where are we going next? Well, when we first started talking about this new definition, I made the observation that a big motivation for doing this was to eliminate the restriction of working in a right triangle. And that's great. I mean, you've seen in multiple ways we have accomplished that. But if you look back at all the examples I've done, I still placed a restriction on everything we were doing. I limited myself to angles that were between 0 and 360 degrees, right? I never went outside of that circle. I also never went negative, right? So that's what we're going to talk about in the next section. What happens when we have angles that are greater than 360 degrees, and what happens if we have angles that are negative?